Welcome to the Futurati podcast. Any member of the Futurati is somebody who believes in the power of the future. We know there's a better world ahead, and we indeed have the power to make it so. In our podcast, we talk to the best minds in the world about the most urgent problems facing mankind today, and we hope you learn as much from them as we do. I'm Thomas Fry, a professional futurist and keynote speaker.
And I'm Trent Fowler, a machine learning engineer and author. Thank you for joining us. Good evening, everyone, and thank you for listening to the Futurati podcast. Tonight's episode is special, both because it's the first time that we're going to have two guests on, and also because it's my opinion that these two are working on a platform that has the potential to revolutionize scholarship, consultation, research, and pretty much everywhere people are thinking about stuff, which is, a lot of different places. So thanks so much for joining us, Jungwon and Andreas.
It's great to be here. Thanks for having us.
Hi. Absolutely. So let's begin where we always do and just have you guys fill us in a little bit about your background, your interests, and what brought you to working on the problems you're working on today. And let's begin with Jungwon.
Sure. So I'll start with an intro to Ought, perhaps.
Sure.
We're the co-founders of Ought. Ought is a machine learning research lab. Our mission is to automate and scale open-ended reasoning. To that end, we're building Elicit, which is an AI research assistant. Elicit uses GPT-3 to automate parts of the research process. And our goal is to make researchers 250 times more productive than they are today. Right now, we're focused on supporting analysts at think tanks, helping them find relevant data sources, structure their arguments, classify data, and summarize publications. For me personally, I am the COO, so I do everything that is not research and engineering at Ought, which is a lot of product-related work, goal setting, recruiting, HR, et cetera. Before Ought, I was at Upstart, which is a fintech company that used machine learning in consumer credit. And so Upstart used ML to predict borrowers' future income and their credit worthiness. I was also at Oliver Wyman, which is a management consulting firm. And in both of those contexts, I often had to make structured decisions under a lot of uncertainty, under high volatility, with very limited data. And so got a lot of empathy for how difficult it can be to make good decisions with limited information, which is part of what we're trying to support at Ought.
Fascinating. Thank you.
Hi, I'm Andreas. So I'm the other co-founder. I do research and engineering at Ought. And before Ought, I spent most of my life in academia. I did a PhD at MIT in cognitive science, and actually started out working in more on the psychology end of things, trying to figure out how do humans learn new concepts, and making probabilistic models for that. But it kind of turned out that the tools weren't really there for that. And so towards the end of my PhD, mostly I ended up working on new programming languages that, you start in one place, you end in another place, new programming languages that support that kind of work, and then followed up on that work in a postdoc at Stanford. And so I've really been interested in tools that can support research and thinking more generally for a very long time. But found it kind of hard to do substantial engineering projects in academia, and found it hard to get the sort of large-scale investment that you need to run these projects. And so I started Ought.
Fantastic. Very interesting background. So there will be many follow-ups to things you said. Let's start with Jungwon. You said that the goal of Ought is to automate and scale open-ended reasoning. So let's just start with open-ended reasoning. What is that? And you also mentioned that you had to make structured decisions under uncertainty. So maybe we could tie that in too.
Yeah. So when we think about open-ended reasoning, what we're trying to do is kind of point to an area where we historically have not seen ML be as useful. So contexts where there's a lot less data, where the quality of the outcome cannot just be evaluated at face value, but could potentially require looking at the process that went into answering the question. These are questions that require a lot of domain expertise, often involve a lot of reading and writing and structuring, as opposed to depending much more on statistical expertise. So we're kind of contrasting that to a lot of the typical ML applications we see today, image recognition is lots of data kind of predicting a fairly well-defined task.
Yep.
And we think the most important questions facing people today and facing society tend to be a lot more open-ended, will the U.S., what's going to happen, what's the future of American hegemony or U.S. leadership on the global stage? What is the future of self-driving cars? What will knowledge work look like in 10 years? Those are the types of questions that we're pointing to.
Fantastic. So why does this process need to be automated and scaled? So we've made it to penicillin and heart transplants and SpaceX with just baseline humans doing what we normally do. Like, what does your platform add to this?
Yeah, I think it's pretty clear that in the last few years, the amount of information that people have access to has exploded. The amount of facts and data, perspectives, nuances, details, events has just has grown tremendously, but our capacity to synthesize that information hasn't kept up. And so it leaves a lot of people, certainly people like me, kind of in a state of analysis paralysis, where all I know is that whatever I believe is probably wrong. And like, I don't know what the right answer is. And frankly, like figuring out the truth is too expensive. We kind of think about it in that perspective at all. We find it helpful as being like truth and good reasoning as things people can afford to pay or not. And right now, many of us aspire to have better opinions, be better read on a variety of topics than we actually can pay the time cost to. And so we're trying to support the kind of synthesis part of that. And so that, we're not just left with a lot of information and not a way to convert that into better decisions in our everyday lives.
So when you started the company, you probably had some use case in mind, something that a certain problem that stuck in your head. If we could solve this problem, this would actually benefit a lot of people. Is there something like that was driving you?
Andreas, you want to take this one?
Yeah, I think the answer is actually no. I think maybe it's a weird answer, but I think throughout my life, it has always been clear that better reasoning just has an impact like throughout all areas of our lives. So like, if I go to the doctor is like running some reasoning process to figure out like what therapy is best for me. Likewise, if I decide what kind of stuff should I eat, if I decide who should I vote for, if, governmental decisions are made. So I think it's really just seeing that if you can improve reasoning, you can kind of improve everything. That is like the thing that struck me as the powerful motivation.
Yeah, when we started working on the research assistant features more recently, we worked very much closely with a think tank. And a lot of the questions they're wrestling with are kind of around emerging technology, tech security, and policy, geopolitical relations, and things like that. So more recently, that's been our focus.
Yeah, well, so let's stick with that then. You say that Elicit is a spinoff from Ought that is aimed at becoming an AI research assistant. So just tell us a little bit about that. Like where are you at in that effort? What sorts of results have you seen so far?
Yeah, so it's a product. It's the name of a product. So it's not a separate entity. We started working on this in October of 2020, so about 5 months ago. We're in the final stages of onboarding our first client, and we really want to kind of embed ourselves deeply within these users and make sure that our tool is very useful for them. We have about 500 people signed up on a wait list that we started kind of collecting a few weeks ago, and have 50 people actively beta testing the product now. I think the biggest kind of product developments that we've achieved since working on this are kind of around, we're working on building a database of questions that have data-driven answers. And I think the other component of it that's really important is we want to build Elicit in a way that makes it very easy for it to grow in a user-generated fashion. So I can talk about each of those.
Well, so I wanted to back up a little bit and just talk about the workflow, because the assumption will be that most of the people listening to this episode will not have seen your demonstrations or played around with the Elicit IDE, although we have and I have. So could you just sort of paint a picture of what a person does when they sit down to use Elicit? Like, what does that look like? Yeah.
Andreas, do you want to take that?
Yeah, I think there's actually a slightly different place I want to start to answer your question, but I will get your question in a moment, which is the way we got to making Elicit the way it is by talking a lot to analysts and kind of watching them work. So, being like, hey, can you screen share and just talk out loud while you work? And then I watch as you open 20 tabs and do Google searches and then assemble things in a Google Doc, and then you cluster the things you find and so on. And so just understanding what are the kinds of steps people go through when they execute research tasks, where some steps are things like you start from a vague question, like what's the future of autonomous vehicles? you go to more precise data-driven questions like how many such vehicles are registered in California per year that you can actually answer, and then you find data sets and so on. And so the way Elicit works is it has individual kind of fine-grained tasks that correspond to these different parts of the research process, where one such task might be operationalize this pretty vague question. Like you give Elicit a vague question, it tells you using GPT-3 or using like other language models, here are some more specific questions that you could use. And that's like one example, but really there are a ton of such like little fine-grained steps in the research process that over time we expect to cover all.
Right. So right now where it's at is I would sit down and say, are tensions between China and the United States going to increase? And then Elicit will use the GPT-3 language model to parse that out into sub-questions that are a little bit more concrete. Like, will there be military activity between the two? Will Chinese presence in the South China Sea increase? Will there be any skirmishes or things like that? And then I think you are working on, or this is in the beta, where you have functionality to go out to data sets and grab those things and sort of bring it all in.
Yes,
Is
exactly.
that basically right?
Yeah, I think the right framework to think about it is there are a bunch of tools in your toolbox, and at various points you'll use a different tool. So like one tool you could use is find relevant data sets. You can also, for the same question about, US-China tensions, you could also use this other tool, which is brainstorm other ways, other versions of this question. So you can choose from many different things to do, which we call tasks, different research tasks.
Yeah, that's just remarkable. So, Jungwon, if you want to pick up where you left off earlier about where Elicit is in onboarding its customers and what you've seen in terms of use cases come out of it.
Yeah, one of the research tasks that we're most excited about is is like basically building towards a database of questions that have been answered by data. So what we found was when we were going through all of these think tank publications or publications in general, they often have figures in the publication that are, that summarize some data that answers part of the overall research question that the publication is answering. So we're using GPT-3 now to extract the captions that summarize each of those figures. And what that allows us to do is build a database of thousands and thousands of questions that people have answered in the course of doing their research and the data that they used to answer those questions. This is so when you search through this database, it's quite a different experience from going to Google, where you'll get a bunch of answers, a lot of, lots of content, lots of long form articles, lots of blog posts. You'll just have a mix of variety. Or it's a very different experience from say going to Quora, where you'll get a lot of individual opinions against a very heterogeneous variety. Here it's a very standardized format. If you start from US AI workforce, you'll get a bunch of results that are what are the major considerations of AI graduates when they are thinking about what they want to do next? Here's a survey that shows exactly what that is. You can go immediately to that. And I think that's a really efficient way to find information.
So it kind of sounds like a targeted self-assembling Wikipedia. So as opposed to just going to the article on AI and education, it looks at the prior data sets, it looks at specific figures that have been pulled out of different papers and sort of puts all that together and serves it to you all at once.
Exactly, because I think we all have this experience when we're reading through a publication, we start reading and then it's lots and lots and lots of words. We're not getting the answer that we want. And often we kind of want to jump to the specific part of those 15 pages that is most relevant to us. We are telling you where in that set of 15 pages should you start.
Are you guys familiar with Arbitol?
Mm-hmm.
Arbitol, yeah. So it was an attempt to kind of do this, and then it's now defunct. And this was in the era prior to GPT-3. But it strikes me that having a tool that's able to kind of expand and contract conceptually or put together different concept chains on the fly would just be enormously powerful, not just for research, but also for teaching and self-education and various other applications as well.
Yeah, I think in a way, Arbitol was before its time. I mean, in some ways, this is still hard, but I think now we're getting close to the time where you can use language processing tools like GPT-3 to, in fact, on the fly assemble an article for you, which I think you just couldn't in the past.
Yeah.
I'm curious as to how you're using GPT-3 to extract the figures. So I think of GPT-3 as just a transformer architecture that's mostly generative. How are you using it to actually find the captions that are relevant to a given question?
Yeah, you can, in fact, just treat extraction as a generation task. So, I mean, for background, all generation tasks have some input and some output. And in this case, the input is, you take the PDF, you convert the PDF to a long text file, which is probably like partially garbled because PDF is a terrible format, and so like it's like pretty messy. But GPT-3 doesn't care that much, and so you can say, okay, here are 1,000 examples of these like garbled text files and their corresponding captions, and then you can like, this is a task where you in fact like want to not just use the kind of pre-trained version of GPT-3, you want to actually like do additional training on top, like fine-tuning. Where you do that on that data set, and then you can just treat it as this sort of like transformative generation task.
One thing I worry about is that if these tools get too good at assembling the information that you're looking for, too good at kind of figuring out what you actually meant to ask, number one, you might have a source of bias creep in. I mean, people keep coming up on the same answers, and this is kind of the only thing you ever see. And also, I worry that there will be less serendipity. I mean, oftentimes it's often the case that when I'm searching for the answer to one question, I find this interesting rabbit hole, which maybe I don't get into right now, but I circle back around to. A lot of that will kind of go away. And I realize that people can always just go back to Google, but do you have any thoughts for ameliorating those problems in the actual platform itself? Like a knob you can turn that just shows increasingly distal concepts when you're searching for a particular thing.
Yeah, we're in the early stages of building these products, which is why it's like really great to talk to people and get their perspectives. I'm sure we could do like a shuffle feature that just shuffles relevant factors. Our hope is that by making this process automated, we can actually give you exposure to many more considerations in the same amount of time. So whereas now some part of your research time has to go into like reading stuff that's not relevant, like for a given hour, you only have so much time to find the relevant stuff. You can't actually read through all of the publications. And most likely as a researcher, your best bet under time pressure is to go to the researchers you already know, the people you already follow, the sources you're used to. Whereas if we can make that much, much cheaper and easier for you, you have more, for the same amount of investment, you have the capacity to explore a much broader set and hopefully get a broader perspective.
That's interesting. So it's probably not going to increase bias all that much. Chances are you were going to go to the people that you kind of trusted anyway. This just makes it a little easier. And theoretically, if you have this shuffle feature, it could actually decrease the net bias in the world when it comes to trying to solve problems like this.
Yeah, I think in practice, I think it has actually like radically increased serendipity for me. So I think one of the things that GPT-3 is most useful for are brainstorming tasks. When you're like, I don't know, here's a list of a few people that I know I should talk to. Tell me other people who could be on this list. Like these sorts of list completion tasks, it's really great for. And I think often I find things where I'm like, I hadn't considered this, but this seems reasonable in retrospect that I otherwise wouldn't have thought of.
Very, very interesting. What are some of the major challenges that you're currently trying to overcome rolling out Elicit or OT, however you want to address that?
Yeah, I think the major challenge in general is non-technical. So GPT-3, there's really a lot of like cool demos of GPT-3, but it's like a very different bar to try to make it actually valuable and like substantially contribute to someone's research productivity. So I think now and even in the future, just learning in great detail what is it that people are doing and what are the real bottlenecks to their research, I think is going to be the main challenge. That said, I think on the technical side, making Elicit learn from user feedback is, I think, just a crucial step that we need to get right. Right now, there's like this experience that people tend to have with GPT-3 where they're like, okay, this is really impressive and seems like so close to useful, but just not useful enough. Like if I could just, teach it just a little bit, it would be so good. But like because it's like this fixed model, you have no way of giving it feedback. And so that like we're trying to get out of that like regime and into the regime where you're like, every time you could go back to Elicit, like it remembers everything you've done in the past and learns from you. And so it's like this kind of environment for thinking that you build up for yourself. And so there are a few different directions we're exploring here. And that I think that is a major challenge and will also remain a thing we'll be working on for a long time.
Yeah. How big a company is OT right now? And then how are you guys funded?
We're a nonprofit, so we're funded philanthropically all through grants. We have 5 full-time staff, 2 contractors, so about 7 people working on the project.
Very early stages.
Mm-hmm.
When Elicit learns from user feedback, does that happen automatically? Is it GPT-3 learning how to formulate better queries, or are you guys tuning it in response to the actions they take? So there are a few different types of learning. I guess it's kind of
I never thought of this before this moment, but it's kind of interesting to think about, like, just like with human learning, there's like learning on different time scales. Like there's some learning that happens for me in the course of this conversation, and then it's like more long-term learning as like memories consolidate overnight. And so I think similarly, like we have different kinds of learning with Elicit as well, where one type of learning is just when you enter a query and you immediately, there's a concept of like starring results that you like, that immediately influences basically on the same screen which results you see next. And then there's a different type of learning, which is kind of the more like consolidated long-term learning, where you're like, well, every time I use a task, I want Elicit to remember the results I start, and I want that, like that research task, for example, operationalizing vague questions, I want that to get better for other people who use it. And that's more a long-term thing where we kind of update the parameters of GPT-3 to kind of favor completions that are like the completions that people have starred.
Okay, so this is going to be a bit of a jarring transition, but I can't figure out a better way to shoehorn this in. Let's talk a little bit about GPT-3, just for people who don't know much about it. I haven't read many of the papers, but I have a background in machine learning. So, Andreas, I'm guessing this is going to be you. Can you sort of walk us through the architecture of the model, whatever OpenAI has released, and how you guys are improving on it?
Yeah. So. I think actually the most important thing to know about GPT-3 is not the architecture of the model. It's that like what it's trained on. I think there's always like some mismatch between like, I think people in ML really like talking about models, but often data sets are equally important. And so for GPT-3, like the data it's trained on is a web crawl data set. It's open. It's called the Common Crawl data set. Has, forget the exact number, but like something like a trillion words or some ridiculous number. GPT-3 is literally just trained as a text prediction model. So what it gets as input is like a prefix of a document, like, here are the first few sentences, now predict the next word. And it just solves this task over and over again. At each point, its parameters are updated to increase the probability of words that in fact occurred next and decrease the probability that like did not in fact occur next. So
is it a word model or like an n-gram or sentence model?
It's a little bit complicated. So it has a concept called tokens, which is somewhere between characters and words. And it is doing like the space of functions it can learn from like the past sequence of tokens to the next token is like pretty complicated. So it's like something more complicated than n-grams. And that's why it's so expressive and can learn, to be so good at predicting.
Is that the secret to its power? Because I assumed it was because you just fed it the whole internet, and if you give it enough data, then it's going to be pretty good. But it's actually these tokens, like mechanistically, that's the key to its ability to generate text.
I wouldn't say it's key, but I think at the time it came out, I think it was an important ingredient. I think people are trying to get away from tokens and just to pure character. I think in some ways that would be purer and more elegant, but I think tokens do buy you something.
I would imagine so. So I graduated from the Galvanized Data Science Immersive, and I built a character prediction model. And it was a recursive neural network, an LSTM, that learned the distribution over Harry Potter, I think, or Atlas Shrugged, one of those, and then it started output. No, Shakespeare. That's what it was. It was Shakespeare, and so then it started outputting its own Shakespeare, and a lot of it was pretty convincing, actually, but partly aided by the fact that Shakespeare is kind of archaic, and people aren't going to recognize fake Shakespeare anyway. But I'm surprised to hear that, I called it Fakespeare, so. That was a lot of fun. I'm surprised to hear that they're going back to characters, though. I would have assumed that n-grams or tokens, larger clusters of characters, would be what you would want to predict, and that would be better. You'd get more feedback when you're updating the parameters. But I guess
the reason is that if you predict characters, you make fewer assumptions, because then, so for example, suppose you're trying to predict all the code on GitHub as well as just words, then if you had a model where you already baked in the notion of words, then it'll just do terribly on that.
That's
and
true.
Then if you have a token model, it'll do somewhat better, but ideally you wouldn't make any assumption about what the structure is of the text that you're predicting.
Wow, that's fascinating. Okay, so you guys have GPT-3, and then you're building on top of that. So how do you add head layers to GPT-3 to train those for task-specific applications?
Yeah, we don't. So there's like a little bit of technical context. We don't actually add like any layers to GPT-3. There is a like work in progress fine-tuning API that OpenAI is exposing, where you can pretty much say, here's a bunch of documents I want to upload, and then train on all these documents, and then you just get a copy of GPT-3 that is kind of specific to the documents that you uploaded.
That's amazing. So what are some of the sorts of things your systems are good at helping with, and what are some of the things it's not as good at?
Some of the things it's particularly useful for are spinning up personal search engines. So it's very easy to create a custom search engine. Any like spreadsheet that you have that feels a little bit like a monster spreadsheet, creating a new research task in Alyssa will be better than trying to Command F or Control F your way through a spreadsheet. In general, we've made it super simple for users to create their own research tasks. Again, kind of going back to the theme of creating your own personal research assistant. So a lot of these new research tasks that users can create can be spun up in minutes. We'll often do them live in demos. So people are using these kind of custom search engines to search over like an export of investments that they got off of Crunchbase, or a list of relevant research questions they've been keeping track of for a very long time, a bunch of documents of like work, draft proposals in progress, searching over publications and things like that. It's also pretty useful for brainstorming. So, like I think Andreas mentioned, one of our tasks is just complete lists. So it can be like, find podcast guests to invite next. And then you give a few examples, Alyssa can generate a few more. And it's not as effective yet for closed form reasoning or very like complete reasoning. So right now it's good at brainstorming a bunch of factors that you should think about, but it doesn't give you a MECE like decomposition. Here are all the factors, and they're all, mutually exclusive and completely exhaustive. But we're aspiring to get there. It's not good at math yet either.
What makes it better as a personal search engine? Like, how does it improve over just Control F in looking for entities like that?
Yeah, the key difference is that it does semantic search as opposed to just comparing words. So you can ask a question like, give me all the personal finance companies in this spreadsheet, and then there's maybe a company like called, I don't know, Mint or Upstart or other companies, and it'll know that those are personal finance companies, and you might otherwise not have found them.
So one of the projects I've been working on in the past was it was an anticipatory thinking protocol called question mapping, and if you start with an unanswerable question in the center, and then you start taking and dissecting that and asking lots of smaller questions around the outside, then it's a way of creating kind of a funnel to get to the big answer that you're seeking. So as an example, if you have this big question, then you can ask the who, the what, the where, the when, the how, and the why surrounding that, and you can ask what came before and what came after, and then somehow you kind of work your way towards an answer by doing it that way. It sounds that there's some similarities to what you're doing.
Yeah, that sounds exactly right. I think it would be interesting if we could get a breakdown of what your process was like. It's possible we could string together a bunch of illicit research tasks to run that sequence that you did.
Okay.
So that is like exactly part of the vision, is to be like, people like you have these intuitions for what kinds of research sequences make sense. Like you take a vague question and then you ask like what, where, why, or things like that. And so if you can take those and make them explicit, then they become these like reusable pieces that anyone in the app like can basically just apply. And so like this implicit knowledge about how to do research well becomes like something that can be like shared and improved.
And that's what you were talking about earlier, where it's a user-generated set of tasks, a set of workflows that people can go through.
Right.
So you said in your introduction that your goal is to make analysts 250 times more productive, which is absurdly ambitious. But I'm curious as to how do you assess that? I mean, it's not just 250 times more reports, right? It's how do you assess that somebody is now 250 times better?
Yeah, I actually think it might not be absurdly ambitious, because I do think, I've been thinking about this because, Trent, you and I have been talking about forecasting just more broadly. And I do think people often underestimate how transformative certain types of technologies can be. So we can be over optimistic locally when we think we're definitely going to get something done by next week, but we can be too conservative about things that are very transformative. And I think language models might be some of those technologies. when we at Odd have been forecasting for quite a bit now, and when we look at some of the goals we set over the last year, I actually think we were too conservative more often than we were not conservative enough. So it's possible the 250 number is still too small. But basically, in this case, the average research project takes something like 9 months to complete, which is just crazy. And if we could use automation to get that down to a day, that takes it from about 250 days to 1 day. So that's kind of how we're thinking about this number. And then from there, once we save you that time, what you do with it is, I think it's still, there's a lot to explore. Maybe it is 250 times more reports. Maybe it's just much deeper insight. Maybe it's a lot more collaboration across industries, things like that.
How far have people gotten in your beta tests towards that goal? Like how much improvement have they experienced in using Elicit so far?
It's still a little too early to tell. Right now, it's a lot of kind of ironing out the kinks of the product. I think certain things that they like certain search tasks that they would have taken them many hours for sure. They can now do in like under an hour, for example. So we've seen some of that work. We're currently embarking on a project now to help a think tank with a classification task. And I think this will be a clear example of where Elicit can add value. So we've seen a couple of instances of projects where, an organization has this large data set and they want to figure out, okay, where are all these companies headquartered? We just have like a bunch of companies. We want to know where they're headquartered, like thousands and thousands of companies. We want to figure out their headquarters for all of them. We have like a long list of professors. We want to know which one of them work in AI. And right now it's actually like a very manual process to do that. And this is a project that people are actively working on by default and have kind of a suboptimal solution for. So we're excited to try Elicit for these projects, and then we'll have a better comparison of how much time it can save them.
That's remarkable. When I first came back from Korea, I started asking around about the number of people who were doing AI work or anti-aging work or theory of computation stuff, and nobody knew. And there didn't seem to be any good way to aggregate that information that wasn't just stupendously manual and required lots and lots of just sitting in front of the computer and putting it into an Excel spreadsheet. So this is really exciting. I mean, I hope that you get there. You've also said that your vision is what is it, 4 years? Every major think tank will be using this to prepare reports. 7 years that will be part of every major literature review and every major research project. So I have a couple of questions about that. First, and then also in 10 years, everyone will be using it for just common everyday tasks. And it's sort of the last part that I have a hard time imagining. I'm sure that if you went to a random person on the street and asked them, would you like to have a better handle on how the future will unfold? They would say yes. But I'm skeptical that they actually care that much about forecasting, for the same reason that I'm skeptical that many people actually care about looking good in a bathing suit, because they don't actually do many of the things required to achieve that goal. So why is it that you think 10 years from now, our mothers will be using this to forecast whether or not we're coming home for Thanksgiving? Like, why will people care so much about getting tomorrow correct?
Yeah. I actually think people do care a lot. It's just, this kind of harkens back to something I said earlier in the podcast, which is that people do want better answers. They want better opinions. They want to do better reasoning. They want to understand the truth more deeply. It's just too expensive and they can't afford it, right? So they don't have time to go through and look at all the, meta research. They don't have time to read all the papers. They don't have the domain expertise. Sometimes they literally get blocked by a paywall. They can't afford it, or they don't have the resources. So our perspective is, let's make it super easy. I mean, as a society, I feel like we should make it very easy for people to get good answers, like thoughtful answers, have, find the truth that makes, that as much as they can. And so I think our approach is like, let's lower the cost down and make better forecasts or predictions like abundantly cheap, so that people don't have to think about whether, this is worth 2 hours of their research time or something like that.
Absolutely. And then what is it about Elicit or Aught more generally that will allow you to capture most of that market share? Because I think a lot of it's GPT-3 and the API, which I don't know if it's public or not, but what's to stop somebody from just replicating this? Like, why will you have a first mover advantage?
Yeah, I think the GPT-3 API in some sense is not the secret sauce. So the secret sauce is more thinking about, to say like why we don't think it's the secret sauce is because we expect, these sorts of APIs will just get commoditized over time. Right now, it's just OpenAI. Presumably, in the future, there will be like, the Google Language Model API, and I guess there
are
is
already a bunch of projects.
There's already the Hugging Face API.
That's true. Yeah.
So those are, we expect over time, those will just be, I don't know, there's like a settings page in Illicit, and you choose which API you want to use. And then the key question really is, given that you have like this kind of powerful API with fine-tuning access, how do you compose together calls to this API to make like good answers to your questions happen? And then I think to give away our secret here, so our secret is kind of a combination of incremental improvement and composition. So you want to define individual, like small component tasks that like are very robust and get better over time. So we get better with every use. Like the operationalized task we mentioned before, or the complete list task, or like some certain specific kinds of search tasks. And then you want to, like, once those tasks are like robust and iteratively improving, you want to make it sure that you can compose those tasks together into increasingly larger workflows. And so we expect, right now there's already like, I don't know, maybe 100 tasks or so on the platform. I think that number will grow. And so like making both the definition of new tasks very easy, making it very easy to like go on the platform and be like, okay, here are the tasks I want to run. Maybe even, even predicting which tasks you want to run is the sort of problem you can give to a language model. So there's like this kind of neat meta idea. So
that seems kind of terrifying. You just wake up one day and it predicted that you would want to see all this research, and it just gives it to you. I don't know. I feel like that's a step too far.
Well, clearly it failed to predict that you didn't want to see it. So
that's true. That's true.
So,
but, yeah.
So one of the topics that I've become known for what this is kind of an insane side note, but I've become known for asking unanswerable questions. And so I've written a couple articles on this topic of unanswerable questions. And so with your model, if you ask an unanswerable question, is this tantamount to dividing by 0, or
just returns 42?
Does it come back with 42?
Can you give some examples of what are some examples of unanswerable questions?
Oh, is the universe finite or infinite? The one I like is, why is there an exception to every rule?
I feel like in that case, it would just return the average answer of the internet, like the collected wisdom of man. It would just sort of give that back to you.
I think it depends on what type of research task you wanted to run. So you could maybe run like a philosophized research task, and it just kind of goes on this rabbit hole with you. Or maybe, a lot of the interest in from our users has been in taking unanswerable questions and figuring out how to make them answerable. Okay. So like trying to figure out a version of that could be proxied with data. It's like, so I think it depends on which task where you wanted to take that.
That's really cool. Yeah. So instead of infinite or finite, it looks at, well, is the what's the volume of the observable universe, or like what's the cosmological horizon beyond which we can't observe anything anyway, so we don't care about it. That's
right. Exactly. Yeah.
Andreas, you said there were 100 different tasks on the Illicit IDE. I only played with like 4 or 5 of them, but I'm having trouble conceptualizing what they would be. So obviously you can complete a list, or you can decompose a question. Like what are some other ones?
So I guess broadly speaking, we can divide it up into search tasks and generation tasks. So operationalized and complete list are examples of generation task. Then we earlier talked about extracting captions. That's another type of generation task. Then there's a lot of kind of language related tasks. So ones that I use pretty frequently are like rephrase this sentence. So I write a sentence and I'm like, this doesn't sound quite right. There must be a better way to say this. So that's another example. Oh yeah, another one like this is like fix the English of non-native speakers like me, where like I give it a lot of examples of like here's like broken English and correct English, and now I can just give it broken English and it turns it into correct English.
We have also done a bunch around generating counter arguments, generate failure modes. Why will this plan fail? Then generate an intervention to prevent it from that specific failure mode.
Wow.
Yeah, like reasoning tasks that are about reasoning steps like that, like list implications of this statement, try to reason about causes and consequences.
Generate examples, like if I say normal distribution, say for example the height of height of humans or something like that. Mm-hmm.
So you noted that the underlying language model is not very good at things like math or strictly logical reasoning, like understanding that you've contradicted something somewhere else. So what are some of the integrations you're looking at doing? Do you think that eventually GPT-3 will be complete enough, or GPT-4 or 5 will be complete enough to handle that itself? Or are you looking at outsourcing parts of it to like a symbolic language evaluator that will note that you're contradicting yourself in different places or something like that?
Yeah, we kind of have a portfolio of bets here. I do think like future language models will get better at math, logic, and reasoning. So you can actually look at, there are kind of scaling curves where you can look at like this is how terrible it has been like when it was GPT-2. This is how bad it is now when it's GPT-3, and it's still pretty bad. But the curves look like they would likely continue for a little bit. So we expect that there will be some improvements there. But then at the same time, I think there are like pretty powerful existing tools out there. So I think using GPT-3 for calculation is probably like not the best use of it. I mean, computers are pretty good at calculation. Yeah. So we do want to integrate with that. And like, basically, I think one way to think about it is whatever tools you use when you do research, you might consider as a potential integration. So if you're like, a thing I do when I use research is I like use a bibliography manager, then that could be a thing that GPT-3 controls. I think it's kind of, GPT-3 is probably underrated as a tool that can be an agent for controlling external tools, and relative to how much people like it for like as a tool in itself. And so like we're pretty excited about using it to kind of generate actions that then like do Google searches, or site searches, or search Google Scholar, or like use a calculator, or like do these sorts of like control over external tool actions.
So right now you can use it to coordinate lots of different tasks.
This is still like a very early stage. We just started with the kind of spreadsheet integration, but I think that is the direction we'll definitely go into.
So what does that look like? How does the language model know what you're after?
Well, you demonstrate it in the same way that you demonstrate other tasks. So you say, here's a log of the things I did. Like I opened the calculator, I entered these numbers, and that is just, that you can just treat that as text. And so if you have a sequence of such steps, you can say, now predict what is the next step. And that's the same sort of prediction problem it's pretty good at.
Oh, I see. You train it to learn that when you're taking these sets of actions, this is the next 3 things you want it to do.
Yeah.
So will Illicit be a product that's for sale then? Or licensed? Or?
Mm-hmm. Yeah, we plan on selling it to these organizations. We have consumers, like the public, just kind of playing around with it for free, and over time we'll figure out exactly what the right pricing model for us should be.
Okay.
So let's say that your vision has been realized, and now forecasting and prediction are just commonplace, and trying to determine when a project will get across the line is just a standard part of the business workflow. How do you think business will change, the world will change? What will be the ramifications of widespread adoption of these techniques and this tool?
I'm pretty excited to get your take on this too, because I feel like you guys also spend a lot of time thinking about the future. But I think it is interesting to think if research were 250 times faster, what else could we discover? What more progress could we make? I think one obvious implication of that is that, if research becomes a lot easier, we democratize access to a lot of this information that's currently kind of held behind, certain domains, like, in certain kind of expertise gates, basically, right? So, today I think basically the vast majority of people have no means to challenge their doctor on anything. And that doesn't mean they should, but like they certainly are not equipped with the information they have to have even a reasonable conversation or like make decisions about their health, things like that. So I expect that if we make research a lot more accessible, we can democratize a lot of this information and expertise more broadly and empower people with a lot more information we should hopefully get to a place where this explosion of information that we've accumulated over the last few years can be synthesized a little bit more, get people out of that analysis paralysis. We've brainstormed about the ability, Trent, you said earlier it would be creepy if you woke up one morning and like Alyssa had predicted what kind of research you want to do that day. But I think a less creepy version that would be exciting is if, like, at any given decision, I had these illicit models of different people whose reasoning approaches I respected, and I could just run them all and look at the results and say, look, oh, these, like, George Washington would have said that I should have done this today. But that's different from what, Einstein would have said. And like, what do I make of that? But just this ability to kind of run through lots of different reasoning approaches and kind of compare them, I think it could open up a whole new type of analysis, like a whole new industry around the study of cognition. Which steps make sense for which process? It's kind of like this next, not like, it's like data science kind of but for like reasoning approaches. I think that's really exciting.
Algorithms of thought.
Yeah, exactly. And like kind of hyper optimize it. Oh, for this type of research project, I should run this sequence, or, things like that. And like compare how did Andreas run this project? Now I can run it. I'm really excited for a lot of the more kind of interactive tasks in Elicit, like this, like generate counter arguments or like tell me why I'm wrong type of tasks, because we could have, as each person could kind of build their own custom debate partner that maybe is like stylistically tuned to actually be convincing to them, and it's like not some angry person that they hate on Twitter. And then it makes the ability to think more critically, think in a more open-minded way, all these like things, values that we aspire to, just like way easier. Yesterday we did this fun project where we kind of compared running Elicit for 5 minutes, like somebody working on Elicit for 5 minutes to somebody working on Google for 5 minutes. And then just like had this explosion of ideas about having this extreme truth discovery competition where it's just like, extreme like games, but for like knowledge discovery. And I think, thinking about kind of optimizing the work of finding information, synthesizing it, thinking critically, and finding ways that we can improve upon it are all just like very exciting opportunities and visions of the future for us.
So over the weekend, we had a plane flying over close to my house here, left the Denver airport, and one of the engines blew up in the sky, and big pieces of the engine started falling down, and I'm just in the back of my mind, I'm thinking, okay, how would Elicit be able to anticipate failures? And some people will think of this as an equipment failure, but I think of it more of a system failure, because there's all these rigid requirements on how the maintenance is done on these aircrafts, and they're checking things constantly. So it's much more than just equipment failure. It's a whole system failure along the way. Is that something that you could tackle with Elicit?
Yeah, I guess one way to think about it is you have like a fixed human budget for inspection. Like this many human hours is reasonable to put into inspection. And then you have one system, maybe the current system, I actually don't know the details of it. There's like, here's how we apportion those fixed number of hours to inspect different parts of the plane. And then there's a question like, is that the optimal allocation, or are there other allocations that are even better? And that question itself is kind of a reasoning question, right? Like, I mean, you can just reason about what kinds of things are how likely to fail. If we observe that a thing didn't fail in the last inspection, then for how long can we go without re-inspecting it? And so like, I think a lot of things like at first feel like, oh, this is just about like the data. You just need to go and look and empirically check it. But once you take a step back, you realize that like data acquisition is itself this reasoning driven thing. And so like is like part of the domain that Elicit could improve.
That's awesome. So Jungwon, you said that Elicit and Ought more broadly have the potential to open up a new way of studying cognition. And I told you I was going to loop back to your backgrounds. Andreas, you studied how humans learn concepts and what concepts are in graduate school. So let's dig into that just a little bit. What are some of the ways you think that Elicit might facilitate that? And what kinds of discoveries do you hope that will be made as a result?
Yeah, that's a good question. I think I'm kind of hesitating because I think the true answer is probably we don't really know. And so with a lot of, this is like likewise the same answer to your previous question, like what happens if we make research 250 times cheaper? I think the true answer is also we don't really know, because like it just changes what you can apply research to. But to still try to give an answer, even though I think it's like kind of made up, is I think humans don't really have the modalities to like read large literatures. So, there's like, we currently like have concepts that are like, individual papers talk about because there are words for them. But maybe if you could just like perceive, what is it like to perceive like 10,000 publications at once and really see like the patterns in them? Like that's a thing that is just not possible for humans, but that is possible for language models. And so there might just be like, again, like things that like are kind of hard for me to construe right now because I can't do this very thing, but there might be concepts that we don't know right now that we might learn by being able to have this like larger scale perception.
One thing I wanted to ask you is, what's your definition of a concept? Because I've cultivated this interest in what in philosophy is called the solution to the problem of universals. So how you define an accurate concept, what it means to actually objectively conceptualize something. So go. What is it? What's a concept?
Oh man, yeah. I don't think that there's a really easy answer. Or I mean, the cop-out answer is kind of concepts are the sort of thing that words refer to. Like whatever the mental representations are that are behind words. Like if I say an apple, there's like some representation I have in my head, and that is a concept. But I think it's a tricky question.
How are concepts formed by the nervous system? So how is the concept of an apple formed over time?
I don't think people understand the brain well enough to really know that. I think people are like very. So I guess people know kind of the very low level of how the brain works, or like here are neurons and firing and so on. And then like there are like psychological theories on a very high level where you can be like, learning concepts is kind of like learning a program that explains the world. But I think you are answering, so your question is kind of about a level in between those, where it's like, well, what are the more systems level, what is the systems level organization of the brain that corresponds to concepts? And I think that no one really knows.
Fair enough. So I alluded earlier to potential other uses for illicit. Have you given any thought to how it might be deployed in educational settings, or like what it might be like to have a third grader work with it to solve a problem or something like that? I mean, it's not just research analysts. I mean, can you make a third grader 250 times more productive? And are you sure that's something you want to do?
We did have a research task that someone created that was ELI 5, explain like I'm 5. So maybe they can help us make that task better.
That would be amazing.
Yeah. I mean, I think at the point where you compress the research process, make it a lot more accessible, you enable people to do more self-guided learning. So, I can much more easily learn about biology without needing a PhD potentially, or I could condense the time of a PhD in a much shorter way, or at least, kind of delve into it as much as I want or go deeper than I might be able to today. So I think it would be really exciting for us to try and make more and more complex concepts or more obscure concepts increasingly accessible to people with less and less starting domain knowledge.
Yeah, or just different domain knowledge. I think Wikipedia kind of gives the same explanation to everyone, but really like the way you explain things to me should probably use the concepts I already know. And so I often have this experience reading finance articles where I'm like, I have no idea what these terms mean, but I think someone could in principle explain those things to me. And so using feature language models to transform explanations and things that make sense to whoever reads them, I think is very exciting.
To cast it in the key of the context that they already have, explain it in terms of neuroscience or behavioral cognition, something like that.
Mm-hmm. Yeah, someone suggested this task to us actually, where they're like, there are often, sometimes like machine learning engineers have their own analogy, then the behavioral economists have their own analogy, then the economists have their, everyone kind of, there are many examples of things where like different disciplines kind of are pointing to the same concept, but use different words. And so translating across academic disciplines is another interesting research task.
So what approaches do you think will need to be taken to train the language models to meet or exceed human reasoning on these kinds of tasks? So right now it's mostly an amplifier for human analysts to be better, but eventually there's no reason to think that GPT-3 can't do a lot of this on its own and just generate the correct conclusions. Like, how far away from that do you think we are, and what would be required to get there?
Yeah, I think that is yet another question to which like no one really knows the answer. So I think, and to further caveat it, I think like models will probably exceed humans in some ways and still be subhuman in others. I mean, I think we already see that where models can do like rote tasks over like hundreds of documents like extremely quickly, like extract the authors from all of these documents and things like that. So in some sense, they've already exceeded humans in some ways, and in others they're like very far from it. I think it's a bit unclear how much improvement we'll just get from larger models, data sets, and compute, and how much we'll need like fundamentally different architectures. I think there are probably at least like I mentioned earlier, like I think there is like some gains in I expect reasoning, math, and logic that will just come from like using larger models and more compute. But we don't really know how far that will take us. That's on the capability side. And then I guess the other side is like more the alignment side where you're like, well, we have models that can in principle do the task, but we might just not have the right mechanisms for giving feedback to those tasks, to those models to really kind of communicate to them what tasks we want them to do. And I think that will be another kind of key obstacle that we need to overcome. In some sense, we already have that problem with like, if you're trying to make Google better, then you run a Google query and then you look at the results and then you're like, well, were these really the best results? And you yourself can't look over all the data on the internet. So your only other like means of evaluating Google is kind of Google-like tools. So you're kind of stuck in this like weird regime where you're like, well, I need to use my tools to evaluate and give feedback to my tools. And I think that will, over time, like that side of things will become more important as capability becomes less of a bottleneck.
So I often think about improving if I'm improving my abilities by 250%, if I'm gambling in Las Vegas and I'm trying to decide which one I should place my bet on, which number, and understanding that there's no total game of chance anymore, that there's always factors that come into play. Do we run the risk of destroying me 250 times better gambler? Does that kill Las Vegas then?
You know it's illicit and not illicit, right? I'm glad that joke landed because I wasn't sure it was going to.
It's an interesting question. I feel like there must be a mathematical way to answer this that I don't know, that I can't do off the top of my head right now.
Yeah,
whether we're going to destroy Las Vegas.
Yeah, okay. I guess it depends on how good you are now.
That's true. Yeah, I'm a terrible gambler, so 250x wouldn't get me very far.
Yeah.
How about this? Do you have any concerns about the way this technology might be used or misused? So I've messed around with the IDE. I mean, it's all very innocuous. I can't even imagine how you would misuse it. But I got to think that if you're 250 times more effective than you were 2 years ago and you can forecast and put these models together, surely there's some mischief a person could get up to. Have you given that any thought? Are there any major failure modes you think might come out of technology like this?
if I'm way better at blackmailing somebody, is that?
Well, yeah, that's not a bad one actually. Yeah.
I think in some sense the default is that, like for language models, is that mischief will come out of them. So I think the easiest way to use language models is to produce like text that looks like real text, and then to just use that in place of real text. We're like, well, generate an news article that looks like a real article defending some position, or like generate some arguments that are convincing, which, and those tasks are a lot easier than tasks that are about actually figuring out what's true, or are about like deciding if some chain of arguments like really makes sense. And so I think in some sense the whole game that Illicit is playing is try to shift the balance from like mischief uses to like uses that these techniques are harder to apply to.
So if our fake news is 250 times fakier,
but convincing as well. Yeah.
Yeah, I think those are real concerns that we have to think about. And then there are also like privacy concerns. A lot of this is coming up with language models now. I feel like mostly I have a list of things we need to worry about and not yet the answers to how to address them. But every single person that works at Aught joined because they wanted to make sure that AI would go well in the world. And, very much aware of the real risk that it could not. So it's something we're like actively talking about, thinking about. Lots of people are doing research on. A couple times I've tried to run related queries in Elicit. It's not unfortunately powerful enough to help me with this problem now, but I hope over time it will be. So I think it'll just be something we have to constantly stay paranoid about and stay abreast of the latest research and other policy developments on. One of the reasons we're excited about some of the initial organizations that we're working with is because from a substance perspective, they're actually directly trying to address this question. Many of them are, in addition to wanting to use AI tools, are studying AI development and what the relevant policy should be. So we're kind of embedded in multiple ways with them.
Fantastic. So we're coming up on the end of our time, and I have to tell you that for as far back as I can remember, I've always had a very strong intuition that even small improvements in productivity or the quality of your thinking would have massive ramifications over a single life. And what you guys are doing is building a platform to do the same thing for billions of people. And so I just couldn't be more excited about it. So I really appreciate you taking the time to talk to us today. And where can people find more information about you?
If they want to sign up for the waitlist, they can go to ide.elicit.org. Our homepage is aught.org, so they can learn more about our mission and the team and our open roles there.
Fantastic.
All right. This is great. Absolutely great.
Thank you so much for having us. It was a lot of fun.
Of course.
Yeah,
Thanks.
thank you.
Thanks.
Okay.
Appreciate
Bye.
it. Bye-bye.